Hello everyone, today we are going to talk about support reactions. To draw a free body diagram, the first step is to remove the beam from its surrounding and include all the loads that are being applied by the supports on our beam. So to find the support reaction is the first step in drawing a free body diagram. And the rule is that if the support resists a motion in one direction, then there is a reaction force in the opposite direction. For example, for this roller does not allow our beam to go downward. That means that there is a reaction force being applied on the beam upward. Also, there is no resistance to motion in the x direction. Our beam could move in x direction. Therefore, there is no reaction force in the x direction because our beam is free to move. Then if we go to the fixed support, it does not allow our beam to move whether in x direction or whether in y direction or even any rotation. So we have both reaction forces in x, in y, and then we have a moment. So we have three reaction loadings because the fixed support does not allow any movement. That means that it's applying load on our beam to fix it. The other type of reaction that is very common is the pinned. So a pin support does not allow motion in x direction or does not allow motion in y direction either. So we have a reaction forces in x and reaction forces in y. But it allows the beam to rotate. So our beam can freely rotate. So there is no reaction moment here, only reaction forces because rotation is not blocked. There is no resistance to rotation. And this is based on the assumption that the pin is frictionless. So that's very important. If our pin has friction, that means that there is some resistance to motion, and then we could use a moment in our reaction loadings. So here, let me clean up this. Same thing for this. When we are looking at this support, we can see that it can freely move along the rod. So there is no reaction forces in this direction. But it doesn't allow this arm to move perpendicular to the rod. Therefore, there is a reaction force. Also, this one cannot rotate. There is no rotation for the rod. Therefore, we have a reaction moment. So whenever we are resisting a motion, then there would be a reaction applied to our system. Let's go to look at another example. Here, we can freely move in this direction. But so there is no reaction force here, but we cannot move in that direction. Therefore, we have a reaction force. And since this one is pinned, that means that we can rotate, and therefore there is no reaction moment being applied on our system. And in finding the reaction force, so for these cases, we don't know the direction, with a positive or negative direction. So in solving problems, we assume one, and then if we find a negative value, that means that the direction that we assumed is incorrect. That's why you see F both in this side and in this side. It depends on the rest of the system to see how it's actually acting. So here, that's a table in your book. You can see for any case you have a reaction. If it's a cable, it's only a tension. Here, if it's pinned, you have only 1/4. Here is a roller. That means that it could roll. So there is no resistance in that direction, only in this direction. That's why you have a force. Same thing with a rocker. If you have a smooth contacting surface, whenever we use the term smooth, means there is no friction. Therefore, is free to move in this direction, along this direction without any resistance, because there is not even friction resistance, so the only load is the perpendicular load. A roller, same story, can move here, but it cannot move in this direction. So it can move in direction A, but not B. And a pin connected, we talked about that. Smooth pin or hinge, same thing. It resists motion in both X and Y, but it allows for rotation. That's why you don't see any moment. And a fixed is a general case which doesn't allow any rotation. Therefore, we always have a moment whenever we use this. You see the term fixed. You can think of it as welding. When you weld something together, when you weld this part and this part, they cannot rotate. And then fixed support, which doesn't allow motion in any direction, in X, in Y, and also no moment, no rotation. Therefore, you're going to have a moment as well. And you could, if we know the angle between our reaction forces, we could simplify it by 1/4. But in general, we know that every force that has an angle with X or Y axis is going to have two components in 2D, one in X and one in Y